Hello, everyone, and good morning. My name is Matthew Urquhart, and I am a master's student at Virginia Tech studying networking and cybersecurity in the Master of Engineering program. Today, I'm going to talk to you about non-controlled data cybersecurity attacks and how they are realistic threats that we really need to do more research on and make sure that we are able to prevent them. I have a lot of personal experience with cyber attacks. I have been both directly and indirectly affected by them. So I think I should be a very good speaker on this topic, and hopefully I'm able to make it interesting for you. Finally, I did read a paper on this before making this presentation. The paper is called Non-Control Data Attacks Are Realistic Threats, and some of the authors are Zhao Chen, Jung Su, and Emery Cesar. So I want to start off this presentation with a question. And it's how many of you have been affected by a cyber attack, either directly or indirectly? And I will say that it's probably a lot more than you think. Cybercrime is very prevalent and rates are greatly increasing. I have a couple of statistics for you on a later slide, but it is probably a lot more than you think. A direct cyber attack, that's going to be one where you were hosting some service online and it was attacked, right? They're attacking a service that you've hosted. An indirect attack is going to be you're a customer of a business or you use a tool online hosted by someone else and that got attacked, and in turn they got access to your data or it affected you somehow. So I used to own a computer repair business in Jacksonville, Florida. And one day, my Facebook page that I used to post updates I wasn't able to log in and it got attacked. The attacker had changed my password and whatnot and was using my platform, since I had already generated a large follower base, to get their information out there, right? And that would have been a direct attack on me. An indirect attack that I've personally experienced was the T-Mobile data breach that happened around 2 years ago. A bunch of T-Mobile customers' data was leaked. And shortly after the attack, I had many fraudulent transactions on many of my credit cards. And also, attackers probably have significant data about me to pursue identity theft would they want to. So it's a big issue that we definitely need to address. Okay, so right now we're just going to talk about some background. So what is a cyber attack? So a cyber attack is a malicious attempt to gain unauthorized access to a computer system, network, or digital device. So you're trying to gain access to something that you don't have access to either steal data, disrupt operations, damage someone's reputation, do something harmful, right? Stealing data, that could be for identity theft. If you're trying to steal someone's identity, I've watched many people do it, then go into a bank and claim that they're another person to try to steal funds, right? Obviously stealing someone's credit card information. Disrupt operations and damage reputation. A big example there would be a denial of service attack. So that's when a cyber criminal tries to make a service go down that somebody is relying on, so that way they can't do their job. So an example that I thought of would be a publishing service for a news company. If there was an attack done on the publishing service that left it unavailable while a news company was trying to report breaking news, that would be terrible for them, right? They're not able to get the news out in a timely manner. Their customers are, anxiously waiting, and people don't want to watch old news, right? It's not interesting anymore. So that's going to significantly hurt the news company's reputation. Two types of cyber attacks that I want to briefly touch on are passive versus active attacks. So a passive attack doesn't affect the actual system at all. The attack is usually just eavesdropping or just stealing data, but the system's operations are unaffected. An active attack does. An active attack is going to affect the system and the program's control flow, and we're going to talk about that in a minute. So here's those statistics that I promised for you on cyber attacks. So a large cybersecurity research firm called Cybersecurity Ventures, they predict that global cybercrime costs will reach $10.5 trillion annually by 2025. And that question that I brought up to you earlier about how many of us have been impacted by a cybercrime, well, IBM did some research into that. They studied many organizations between March 21 and March 22, right? So a year-long span. And out of all of the organizations that they asked and, investigated to see whether they had been a victim of a cybercrime, 83% of them had been a victim of some sort of cyber attack in a year. So that really shows that cyber attacks are incredibly prevalent and more research needs to be done quickly to try to mitigate these effects. Also, many cyber attacks are never reported, especially from very small businesses. So these numbers could be even higher than what we see. So one type of cyber attack that we need to learn about are memory corruption attacks. So all programs have memory, right? That store, all the program variables and the program's logic and control flow, right? So all programs require memory to operate. And a memory corruption attack is a common type of cyber attack that exploits vulnerabilities in software to overwrite or corrupt data in memory. So the attacker is going to go after memory in a program to try to make the program act in an unintended way. Some motivation for this would be to steal data, right? So if they're able to get into the data memory for a network, they might be able to get that network to share data with them that we normally wouldn't want to share data with them. They might be able to control a system or an application, or again, that denial of service, right? To cause a program to go down, right? If you were to delete a program's memory or alter some variables that the program needs to run with gibberish, right, then the program may not be able to continue its operations and it might go down, causing a denial of service. So finally, in this introduction section, I just want to briefly touch on control flow because we will be talking about non-control flow attacks here. So we need to know what control flow is in order to understand what a non-control flow attack would be. So the control flow of a program, it refers to the order in which the program's instructions are executed. And how I like to describe that is when we as programmers, I write a lot of applications myself. And when we write applications, we work in a methodical way, right? So we have a methodical process and we try to ingrain that in the program that we're writing. We write the code in a logical order and we come up with steps that the program needs to run to achieve its desired outcome. So we say, okay, the program needs to do this first, then this, and so on, right? And when that's all done, that structure of the program is going to be the program's control flow. It's going to be how the program is going to operate, what operations it's going to do, and in what order. So some mechanisms that we use would be conditional statements. So there are statements in programming that say, if this variable is of this value, then do this. We could also have loops, which repeats code based on a certain condition until that condition is not met. Function calls as well. Some types of control data are going to be return addresses and function pointers. So those are data that tell the application where to look on your hard drive for the information that it needs. So by overwriting control data, attackers can redirect the program's execution to their own malicious code. And I think we've gone over that a little bit, but that is what we are trying to prevent, right? If they're able to overwrite the data, then they can cause the application to behave in unintended ways and pursue their own goals. So to go into the next section, what if attackers cannot hijack the control flow of a program, right? Let's say somebody comes up with a bulletproof mechanism for protecting the control flow. Are attackers still able to compromise its security? Is it possible? If they're not able to target the control flow, is it possible to still compromise a program's security? And this is where your non-control flow attacks are going to come into play. So our next section is on non-control flow attacks. So let's jump right into it. So what is a non-control flow attack? So it's going to be an attack that targets and corrupts non-controlled data within a program to compromise security. So these are going to be application-specific vulnerabilities, right? They're going to exploit logic errors in the application specifically, and that could be to pursue a data-only attack, to steal data, or to cause a denial of service, or something like that. So can anyone think of any reasons why attackers might find non-control data attacks appealing? Well, I think we touched on one in a previous slide, but the big one that I thought of is, well, control data attacks are by far the most popular, so there are many mechanisms that we already know about on how to defend them. So non-control data attacks might be significantly easier for an attacker to achieve. And that is exactly what I found in my research. So when we go on to the motivation for a non-control data attack, the number one reason is that there are already advanced defense mechanisms for control data attacks. They are more difficult to detect and prevent because of these advanced defense mechanisms, right? The defense mechanisms are not only able to prevent them in many cases, but the control flow attacks are also very easily detectable. And once they're detected, then the program can be shut down before too much damage can be done, hopefully. These attacks are tailored to specific applications and vulnerabilities, meaning that they might have less side effects in the system, and therefore they would be easier to execute without them being detected, right? And then they are equally effective for many motivations. So at the end of the day, a cyber criminal has a motivation to do what they want to do. And if a non-control data attack is able to do what they want, then they don't care really about anything else, right? They're equally effective for the motive that they have. So just a couple of ways that we have found to protect the control flow, right? There are many mechanisms that already exist. I'm not going to go into the details of these, but some of them are called stat guard, live safe, format guard, control flow integrity, and non-executable memory. The photo that I have on this slide shows a Windows settings menu that shows the control flow guard is on for the Windows operating system, right? Long story short, there are many ways for us to protect a program's control flow. That's been the subject of research for years to help prevent these attacks. So they can be very difficult to do now. So hardware transient errors. So these are temporary malfunctions in hardware that can cause data corruption or unexpected behavior. And one way to pursue a non-control flow attack is to exploit one of these errors, use one of these errors to your advantage to inject your malicious code to go ahead and start your attack, right? So these malfunctions are not bugs in the program or anything. These are just going to be malfunctions that are very difficult to avoid. There's always going to be some issue with hardware that can arise due to an environmental trigger. So maybe we have too much radiation on a control board and it caused a basic error, right? But these are errors that just occur once and go away, and there's really no rhyme or reason. So, but radiation, electromagnetic interference, small manufacturing defects, these can cause issues. Now, there's also intermittent and permanent errors that are shown in the image on this slide. So intermittent errors, they occur, they disappear, occur again. These are typically bugs in the program that can be resolved, and then permanent errors will occur until they are fixed. We're talking about just transient errors. These are small little errors that will occur once and go away. So such errors can cause some security vulnerability, such as a corruption of firewall rules, if that's where the error occurs, corruption of a Boolean variable that's used in a security critical decision, right? They're going to cause an error and the attacker can then exploit. So moving into the next section, what kind of data do you think could be critical to the security of an application besides control data? So what data are we going to target in our non-control flow attack, right? That's what we're going to talk about in the next part of this presentation. So this data is called security critical data. So this is the type of data that attackers are going after with these non-control flow attacks. We're going after security critical data. So what are some types of security critical data? So we have configuration data. So all applications have data that specifies parameters like file locations, access control policies, and most importantly, security settings. And this data tells the app where to look for important files that it needs to conduct its operation. It tells it where the security control application is, right? How to run the security control application. So all applications have configuration data, and it basically just tells the app how to run and where to look for things. The importance of this data is to control the application behavior, right? Especially at runtime. So when you boot up the application, how does the application boot up? What is the boot sequence? Where can it find its important information, right? That's all going to be part of configuration data. And corruption of this data could then bypass security policies if the security software does not engage with the program properly, allowing hackers access to the data. One example of this type of attack is going to be a CGI bin path directive attack on a web server. We're going to talk about this in the example attacks section of this presentation in just a little while. This graphic that I have down here shows a server, and you can see the configuration data, and the server needs constant access to the configuration data to figure out how to perform certain actions that the user is requesting and how to keep itself running smoothly. So another type of security critical data is user identity data. This one pretty much speaks for itself, but this is going to be things like user ID numbers, passwords, permissions data. If you've ever gone into the File Explorer on your Windows computer and it says you don't have permission to access this file, well, the permissions data is telling it that you are not an administrator of the computer, so you're not able to access some settings, right? The importance of this is going to be confidentiality and access control, right? We don't want people that are not familiar with how a system works to be able to access the very high level settings of the system, right? That could cause a lot of problems. We also don't want hackers, again, to be able to get into it. An example of this would be logging into a remote server with SSH without your permission, without permission of the server host, and we're going to talk about this in a little bit, right? The next security critical data is user input data. So this is data provided by the user to the application. The biggest example of user input data is you inputting data on a keyboard and you want the application to act on that somehow. That's user input, right? You're putting that data into the computer for the application to use. One example is that I built a meat thermometer program a few years ago in an AP computer science class in high school. And this program allowed the user to input a particular type of meat, whether it be beef, chicken, or whatnot. And then it asked the user for the temperature of the meat while it's cooking. And it told the user about how much longer until it was done and what temperature that it needed to get up to. So it was just a program to help people cook meat, but the user would have to input the temperature of the meat into the application for it to go through its logical flow and let the user know what's going on. So again, user input can control an application. Most user input is validated to enforce security policies. So what does that mean? If you input an invalid number or so into the application, the program shouldn't malfunction and it should let you know, hey, this is an invalid value. Another example of an attack here is going to be an email newsletter sign-up attack, and we'll talk about that in a bit. The last type of security critical data that I want to mention is decision-making data. So these are data or variables that are used in security-related operations. So a lot of these are going to be Boolean variables. So we're going to have conditional statements in our programs that say, if this value is true, then do this. If it's not, then do this. And if that Boolean value relates to the security system of the program, if it's corrupted, it might be able to bypass security checks and allow unauthorized access, which is something that we need to try our best to avoid. Decision-making data, that can be modeled using a decision tree. So I have that here as an image off to the right. So at the front, this is an income-based decision tree, and it's going to use the user's income, which is going to be a variable, to control what the program is going to do. So if it's more than $50,000, then it's going to classify its credit history as low or moderate risk, depending on other variables. But if it's between $20,000 and $50,000, then it's going to just go between low and high risk, depending on these other things. And if it's less than 20K, it's going to just classify it as immediately a high risk applicant, right? So an example of an attack would be to maliciously change firewall rules to block malicious network traffic, and we will talk about that as well. So before we move on to the next section, can you think of any other types of data that could be critical to security? So this next step is going to be validation of attacks. These are attacks that are outlined in the paper, attacks that were unfortunately successful, and these are outlined in the paper to really show the validity of these non-control data attacks and the importance of defending against them. So the first one is a format string attack. So this attack targets a format string vulnerability, which is a type of bug that can allow attackers to write data to arbitrary memory locations. In the case of the paper, the attacker exploits the vulnerability in the FTPD server software to overwrite the memory location where the user ID is stored. And when the attacker did that, they were able to give themselves administrator access and gain complete control of the server. So they were able to attack this string that had a variable in it that tells the machine how much access to give them. They were able to change this variable to 0, which represents the root user, and that was able to give them full administrator access to the server to do what they wanted to do. And that's a very bad thing. The next example of attack that's outlined in the paper is a heap corruption attack. So the attack, it's targeting a heap overflow vulnerability, and that occurs when a program writes data beyond the allocated memory on the heap. So the heap, let's say, can only store 64 kilobytes, and the user and the program tries to write 128 kilobytes, right? It's trying to write too much. The attacker is then able to exploit this vulnerability to modify the CGI bin configuration string, which is a string that specifies the directory where scripts are located. And by changing that, the attacker is able to execute their own malicious scripts as part of this application. Again, they were able to gain root privileges by doing this. That was just the example given in this paper, but if an attacker is able to execute their own scripts as part of a program, they may be able to tell the program to spit out data for them and steal data and do a lot of other bad things, right? Next, we have a stack buffer overflow attack. So this is similar to the last one, which was a heap. This is going to be a stack buffer, again, an overflow vulnerability. And that occurs when the program writes data beyond the memory on the stack. The stack is where programs store temporary variables and things that it needs to be able to operate. Every program has a stack. The attacker was able to use this vulnerability in a web server to modify a register on the stack that holds a pointer to the URL requested by the client. Unfortunately, by changing this, the attacker can bypass a security check and send the user to a malicious site that, to hopefully install malware on their computer, something like that. So next we have an integer overflow attack. So, this attack exploits an integer overflow vulnerability, which occurs when a program tries to store a value that is too large for the data type. So as an example, let's say an integer can hold a maximum value of 64,000. If the program tried to write a value of 128,000, then that would be an integer overflow problem. An attacker is then able to exploit this vulnerability in an SSH server in the paper to override a Boolean variable that is used in the authentication process. By changing this, the attacker was successfully able to bypass complete authentication, and they were able to just get into the server without even verifying who they were. That is incredibly dangerous, and again, they were able to gain root access to the server in this method. The last type of attack that I want to talk about that was outlined in the paper is going to be corrupting file descriptors. So file descriptors are integers that index the kernel table of open files. Basically, what this means is that they are integers that tell the system where to look for things on your hard drive, right? They can change these to compromise the security of the file system. If these variables are changed, then the program is going to think to look elsewhere for a particular file, which might contain a malicious file that then the program is going to try to access as part of its normal operation. If you want to learn more about all of these attacks that are outlined in the paper, I greatly encourage you to read the paper. I think it's a great paper, and the link to the paper is going to be on the last slide, as well as my email address. You can either leave a comment on this video or reach out to me. I'd be happy to answer any of your questions about these attacks. But based on what we have discussed, I hope this opens your eyes into non-control data attacks, and I hope this at least shows to you that they are realistic threats that we do need to be doing research on in the future, right? So based on these results, do you think that non-control data attacks are a realistic threat? I definitely do. These are 5 attacks that the writers of this paper were able to successfully exploit in their own experiments. That are these non-control data attacks. So just a quick recap for a conclusion. So non-control data attacks are a very serious threat and a growing threat to cybersecurity. These are going to be application-specific vulnerabilities that are targeting security-critical data, which could be your user identity data, and so forth, right? These are difficult to detect and prevent with current prevention methods. One flaw of this paper, I think, is that it doesn't really talk too much about how to prevent these non-control data attacks. And personally, I think that's just because there hasn't been much research done into this. But these attacks can be equally effective to conventional attacks, and the frequency is significantly increasing as more and more effort gets put into designing a prevention method to these conventional attacks, right? So as we develop more systems to prevent control flow attacks, attackers are going to begin focusing their efforts on these non-control data attacks that we can't as effectively defend against, and that's going to cause the frequency of these attacks to significantly increase. So now this is going to be a call to action. So what must we do now to mitigate these attacks? Well, one thing that I already said is that we need to continue researching them, but rather than just researching the types of non-control data attacks, right? And discovering more vulnerabilities, because that's completely useless if we're not doing anything with that information. So rather than that, we need to start focusing on how to prevent these attacks before we continue doing research into that. Yes, it's important to identify vulnerabilities, but if we're not doing anything, then what's the point in doing it, right? So we need to start researching prevention and defense mechanisms. We need to educate, and we need to educate both users of software and developers. Obviously, we need to educate developers about this so they can hopefully make their programs resistant to these type of attacks, right? But we also need to educate the user of these programs on how they can help protect themselves against these attacks. User education is a big thing in cybersecurity, especially with phishing and malware attacks. What's the best defense to not getting a virus on your computer? Well, it's to not download it in the first place. So how can we educate users to help them determine whether they could potentially be getting themselves into trouble while on the internet, right? And we need to continue researching what leads to these attacks. So finally, how do you think we can improve our defenses against non-control data attacks? I'd love to talk to you about this. Please leave a comment down below. But what do you think? How can we improve our defenses against this right now? And that's it. Thank you very much for listening to my presentation. My email address is right there on screen, urquhartmatthew@vt.edu. And there's also the link to the paper if you would like to read it yourself. Thank you very much for listening.